Hi, so today we will learn about efficiency of a source of EMF and efficiency of an electrical device. So we know that efficiency of anything is equal to output power upon input power. And output power is power dissipated, consumed at external resistance. And this is equal to IV upon efficiency. Okay, and input power is equal to IE. I is cancelled, and this is equal to V is equal to IR, and E is equal to, okay, from equation I is equal to E upon R plus internal resistance R. Therefore from here E is equal to I into R plus R. So this is your efficiency of a source of EMF, R upon R plus R. Now efficiency of any electrical device is equal to output mechanical work done. Mechanical work done divided by electrical work, or mechanical power, better right, mechanical power, output power upon electrical input power. So on the basis of this, we'll be finding what is maximum efficiency of any source of EMF. So firstly we will do this question. A battery of EMF A and internal resistance R is connected across a pure resistive device. Resistance given is R. Okay, let me make a diagram. Internal resistance is R. EMF A, here you have battery, and it is connected to an external resistance R. Okay. So that the power output of the device is maximum when there is a perfect matching between external resistance and source resistance, that is small resistance, small r. Determine the maximum power output. Okay, so power is equal to I square R. Now I is equal to EMF upon R plus internal resistance. So power is equal to E upon R plus R whole square to R. This is equal to square upon r plus r whole square, and this is equal to a square r upon, okay, you can convert this a plus b whole square kind of thing into a minus b, okay, let me do in this way, a minus b whole square kind of thing. Here you have you need to add a term 4rr. So you can convert a plus b kind of thing into a minus b whole square kind of thing. So power is equal to this much. Now power is maximum when denominator is minimum. Now it is assured when r is equal to small r, or you can say r minus r is equal to 0, because internal resistance and external resistance cannot be changed, these are constants. So only this term can be reduced and it can be made 0, and it implies that external resistance must be equal to internal resistance. So now, what is the efficiency of source and what is the maximum power? What is maximum efficiency, maximum power? Now, maximum power is equal to E square R upon 4RR. Now when you replace this capital R with small r, you find that maximum power, power max, is equal to E square upon 4R. So from here, what is the maximum efficiency of a source of EMF can be obtained? Maximum efficiency of a source of EMF is equal to R upon R plus R, that is equal to R upon 2R, means half, means maximum efficiency is equal to only 50%. What is power output of the source if the battery is shorted? What is the power dissipation inside the battery in this case? So when battery is shorted, now external resistance R becomes equal to 0, because now current will not flow through this circuit. Current will directly flow along this shorted path, so R becomes equal to 0. Now power dissipation in the cell itself is equal to EI, and this is equal to E into I is equal to E upon, here R becomes equal to 0, so only resistor is internal resistance, so this is equal to E square upon R. So this is power dissipation in case of shorted cell. Power dissipation short-circuited cell. An electrical motor runs on a DC source of EMF E and internal resistance R so that the power output of source is maximum. Output power is maximum when current drawn by the motor is E upon 2R. Okay. So, power output of a motor is equal to terminal potential difference V into I. And we know that V is equal to E minus IR into I. This is power output. Now for maxima, suppose this is a graph of P versus I. At maxima, the curve, the slope of curve, slope is equal to, happens to equal to tan theta. Now at maxima, tan theta becomes equal to 0. So for maximum value, we need to find the slope of P versus I, means we need to differentiate P with respect to I for maximum power. Okay. For maxima, dP upon di means slope must be equal to 0. So let me differentiate it with respect to I. So dP upon di is equal to EI. Okay, E minus 2 I square. So it is equal to 2I into R. And this must be equal to 0. Therefore, E minus 2IR is equal to 0. Therefore, I is equal to E upon 2R. So, for maximum value, current should be equal to E upon 2R. Now question 2. So that the power output of electric motor is maximum when back EMF is half the source EMF. What is back EMF? So in motor we have inductor coils made up of copper only. And in concept, R of this coil R is equal to 0. Okay, so what is back EMF? If current go on changing, magnetic field associated with current also go on changing, and this changing magnetic field induces an EMF. That EMF opposes the cause itself. If EMF induced is E dash, so it will oppose this cause EMF capitally. So the two EMF will be in opposite direction. Now, and suppose battery EMF is, internal resistance is R and EMF is E. Now current I must be equal to net EMF, current I through the circuit. And net EMF is the two EMFs are in opposite directions, so let me subtract one from the other one and divided by R. As in concept, the resistance of an inductor coil is 0. So this is I. So in case of maximum power, maximum P, for maximum value of power, P max, this must be equal to 0. So for maximum power you have current I, and therefore if you equate the two currents for maximum power, E upon 2R is equal to E minus E dash upon R. So E is equal to 2E minus 2E dash, and it implies that E dash is equal to E by 2. So back EMF should be half of EMF provided to the inductor coil. For maximum power, back EMF should be half of EMF of the cell connected to a inductor coil.